Okay, so welcome everyone again to the first webinar from the Language Institute. And it is the first webinar of the year 2022. And today we are very honored to have Dr. Araya Ramsin from the Language Institute of Chulalongkorn University joining us and giving us knowledge about quasi-experiment design and analysis. So we will give her a very warm welcome and maybe virtual hand clap. So, right, and thank you very much. And so I shall, right, thank you very much and welcome.
Okay, so can I start now? Sure, okay.
Of course,
So,
of course.
Yeah, okay, Ka. So thank you everyone so much for being here today. And thank you for the very warm welcome, Naka. Okay, thank you so much for that. And thank you, LITU, for inviting me to be today's guest speaker. It's a great honor to be here. Okay, so hello everyone. Thank you for your interest in this talk session. How's everyone doing this morning? It's Sunday morning. Are you doing good? Yes, okay. So yeah, it's Sunday morning. So thank you so much for being here. So now I'm going to share my PowerPoint slide. Can you all see the slide? Yes, all right, thank you. Okay, so my talk today is going to be on quasi-experimental research and analysis. And this talk is actually intended for graduate students conducting or planning to conduct a research study. But everyone interested in experimental research, designs, and quantitative research is welcome too. So I might not know a whole lot, but I'm going to share what I know. Okay, so hopefully you'll find this talk helpful for your study. So first of all, let's first take a look at the research process. What are the steps in conducting a research study? What is the very first thing researchers have to do when they want to conduct a study? Anyone? What would be the very first thing that we have to do if you want to conduct a research study? No, okay. So the very first thing that you have to do is that you have to first identify a research problem. Okay, so you begin a research study by identifying a topic to study. It can be an issue or a problem in education that needs to be resolved, okay? And in this step, you need to also develop a justification for studying your topic, okay? And suggest the importance of the study, like why you have to study this problem, something like that, okay? And what should be the next step after you can come up with a good topic to study? The next thing that you should do is to review the literature. It's very important to know who has studied the research problem that you plan to study or you plan to examine. Okay, so to review the literature, you may locate summaries, books, journals, and index publications on a topic. And then you have to selectively choose which literature to include in your review. After that, you have to summarize the literature in a written report. Okay, so after you have read a lot about other, like after you have read a lot, then you know enough about your topic, right? So the next step is to specify a purpose for your research. Okay, so here, if your research problem covers a broad topic of concern, then you're going to have to narrow it down before you can come up with the purpose statement. And this statement will convey the overall objective or intent of your research. Okay, it is the most important statement in your research study as it contains like major focus of the study, the participants in the study, and the location, for example. Okay, so this is quite important. And then after that, you will start the data collection process. Okay, so here collecting data means identifying and selecting individuals or people for your study. And you need to also obtain or get the permission in order to collect their information or like information from them like that. Then you can gather information by asking people questions or observing their behaviors. But first you have to get permissions, okay? And this step will introduce a collection of, okay, one second. Okay, so this step will produce a collection of numbers. Okay, so your results can be numbers like test scores or frequency of behaviors, or words if it's like qualitative. So that could be like responses, opinions, or quotes. Okay, so once you identify these individuals or peoples and places, then you write the method or procedure section in your research studies. And these sections offer detailed technical discussions about the mechanical and administration of data collection. Okay, and after that, then you can analyze and interpret your data. During or immediately after data collection, you will need to make sense of the information that you obtain from your participants. So analyzing and interpreting data involve drawing conclusions about the data, representing it in tables, figures, and pictures to summarize it and explaining it in conclusion. Okay, in words to provide answers to your research questions, okay? And then the very last step is to report the research. Now, after conducting your research, now it's time to write a report and distribute it to your audiences. And the audiences for research can vary, okay? And can include academic researchers who contribute and read journal articles, or faculty advisors and committees that review PhD dissertations, for example, okay? So your structure for the research report will vary for each audience. However, in all types of reports, you will need to be respectful and avoid language that discriminates on the basis of like genders or sexual orientation, race, or ethnic group, for example. Okay, so you have to be quite careful. All right, so now, apart from all the steps, conducting educational research is more than engaging in the major steps that we have just discussed in the process of research. It also includes designing. You have to make a decision whether you want to write the research in one of the two major tracks. And the two tracks that I'm talking about are quantitative research or qualitative research. Okay, so before I explain about the two type of research, can you take a look at the information in these two boxes, and can you tell me which one is quantitative and which one is qualitative? Okay, so I have information in the green box and information in the blue box. Okay, so let's see. You can actually turn on your microphone and you can actually speak with me. Okay, so let's look at the first box together. So with this research design, it allows you to go deeper into a problem and gain a human perspective on it. Okay. It also provides in-depth information on factors such as experiences, opinions, motivations, behaviors, or descriptions of a process. And this research method also, data in this research method is often recorded in the form of field notes, sketches, audio tapes, photographs, and other suitable means. Okay, so what research are we talking about here? Is it qualitative or quantitative, the first one?
Qualitative.
Qualitative, everyone agrees? Yes, of course, I'm talking about qualitative research. Okay, so of course, the other one should be quantitative, right? Okay, so let's take a look at some descriptions of quantitative research. So with this type of research, numbers and statistics are used to quantify change and often expressed in forms of digits, units, ratios, percentage, for example. And it is, okay, this quantitative research is useful for evaluations that involve a large group of participants or sample population. It is not intended to provide in-depth understanding. However, it provides a broad picture of a particular context with precise findings. Okay, so the focus of my talk today is going to be on the second one, quantitative research, and in particular, the quasi-experimental design. Okay. So now, when conducting quantitative research, researchers collect and analyze numerical data. So their focus here is on the numerical analysis of data. different computational techniques are used, and quantitative data is often arranged and presented in tables, graphs, and charts. Okay, so this is like overall about quantitative research. So why do people use quantitative research? What are the advantages of quantitative research? Some of the major advantages of using quantitative methods are, okay, first one, let me move, I cannot see my screen now. Okay, let me move this down here. Okay, so the very first advantages is that the quantitative approach allows you to reach a larger sample size. So when you have the ability to study a larger sample size, then it is easier to reach an accurate generalized conclusion. A larger sample makes it less likely that the outliers in the study group can adversely impact the result that you want to achieve. Okay, so that's the first good thing of using quantitative research. Now, the second advantage of quantitative research is that collected data is reliable and accurate. As quantitative data is collected, analyzed, and presented in numbers, the result that you get will be extremely reliable because numbers do not lie, okay? And they offer an honest picture of the conducted research without discrepancies. Also, quantitative research offers no scope for personal comments or like feelings or biasing of results. So the results achieved here are numerical, and so they are fair in most cases. The next advantage of this type of research is that data collection can be done quickly when using quantitative research. So the involvement of statistics, conducting and analyzing results is quite straightforward and less time consuming. So that's the good thing about this one. And the next advantage is that the research performed with quantitative approach is anonymous. So the anonymous nature of quantitative research makes it useful for data collection. Why? Because people are more likely to share an honest perspective, and especially when they are guaranteed that their feedback won't come back to haunt them. Okay, so they feel better to help you to provide information about themselves. Okay, so next one. Quantitative research doesn't require direct, okay, let me move this one right. Okay, quantitative research doesn't require direct observation to be useful. So that isn't a requirement to directly observe each participant. This advantage creates a better response rate because people have more time and less pressure to complete the work, okay? Because surveys can be sent out to people without the need to have them in the room, to physically be in the room with you while they are providing answers. So that's good about it. Okay, so now let's see. There are like, okay, so here, take a look at this nice diagram. I didn't create this one myself. I got it from this website down here. So quantitative research can be categorized into 5 groups. Okay, first one is survey research. Second one, descriptive research. And then correlational research, quasi-experimental research, and finally experimental research. And of course, I'm not going to be talking about all of them here. Today, we will look at quasi-experimental research and this one too, experimental research, because these two are quite similar. So first of all, what is an experiment? When do we use it? Do you have any idea what it is? Anyone? Okay, all right. All right. So a true experiment. Okay, actually, let me go back to this one more time. Okay, so here, experimental research sometimes is called true experiment. Okay, so this one is like quasi, it's like half, it's not like that complete. Okay, so this one is like a true experiments. Okay, so what is an experiment? A true experiment is a method of data collection that is used when you want to establish possible cause and effect. You want to see whether something causes the other thing, like that. Okay, between your independent and dependent variables. And true experiments are considered the most rigorous research designs, like the best one. Okay, so if you can use this one, then you should use it because it's the best one. Okay, so what makes a true experiment? There are three main criteria that have to be met in a true experiment. Okay, first one is control group and experimental group. And the second one is researcher manipulated variable. And the last one, random assignments. Okay, so now we are going to take a look at each one more closely. So first one here, control group and experimental group. What does it mean by that? So control and experimental groups are required in true experiments. A control group refers to a group of research participants that resembled or are the same as the other group, as the experimental group, but people in the control group do not receive the experiment treatment, okay? And then you need another group, which is called an experimental group. So here, people in this group of research, these are the people who receive the experimental treatment, okay? And you can have more than one experimental group, okay, in your study. The second criterion is that researcher manipulated variable. In a true experiment, you have to manipulate the variable that is hypothesized to affect the outcome variable that is being studied, that you are studying, okay, yes to say. All important variables or factors that might affect the outcome must be completely controlled. Otherwise, it won't be called an experiment or true experiment. Okay, and the last one, the last criterion is random assignment. This is very important, okay? So research participants have to be randomly assigned to either the control or experimental group, okay? And each participant will have an equal chance of being assigned to each group. With random assignments, the researcher can be certain or can be sure that the differences in the groups are due to chance, okay? So these things are required in a true experiment. Okay, so although true experiments are preferred design, it is not always possible. Sometimes it's impossible or practical to control all the key factors. And also in many experimental situations, like in education, for example, researchers will have to use intact groups, like a group of students in one class like that. Okay, they cannot like randomly select them sometimes like that. So researchers have to use intact groups of participants in their studies. And this might happen because of the availability of the participants or because forming like artificial groups is not allowed. So it becomes necessary. So that is why you have to implement a quasi-experimental research, okay? Like, for example, if you want to study a new English program, okay, this study may require using existing fourth grade classes and assigning one as an experimental group and the other as a control group might not be possible. Okay, so you have to kind of use people in intact group like that. Randomly assignments may not be possible because like randomly assigning students to the two groups would disrupt classroom learning. Okay, so sometimes you just can't do it. Okay, so you have to implement quasi-experimental research. Okay, and because educators often use intact groups like in schools, colleges, or classroom sections, in experiments, quasi-experimental designs are frequently used in education. Okay, now here we are. So now we are going to take a look at quasi-experimental research. Okay, so let's see what it is. So a quasi-experimental research is a non-randomized study design that is used to evaluate the effect of an intervention or your treatment, okay, whatever you have. So both true experimental and quasi-experimental designs have the same purpose of examining the cause of certain phenomena. Okay, they have the same purpose. And the intervention can be a training program, a teaching strategy, a policy change, or a medical treatment, anything that you want to test, okay, anything that you want to measure or examine. Having a control group is not required, but if you can have it, it provides a higher level of evidence for the relationship between the intervention and the outcome, okay? But sometimes it's just impossible, but if you can, then it's good. Now let's take a look at some examples of quasi-experimental designs. Okay, so now I'm going to show you 4 types of them. Okay, first one is called one group post-test only design. Okay, second one is called static group comparison design. And the third one group pre-test post-test design. And the last one, separate sample pre-test post-test design. Okay, so now I'm going to provide information on each one so you understand, you have a clearer picture what each one looks like. Okay, so let's look at the first one group post-test only design, also known as one-shot case study. Okay, please pay attention to this description that I'm going to show you now, because after I've told you about all 4 types, then I'm going to have a quick test to see if you know what each one is. Okay, so pay attention to the details of each one. Okay, so one group post-test only design or one short case study. So in this type of quasi-experimental experiment, the outcome of interest is measured only once after a non-random group of participants is exposed to a certain intervention. So after, not before, okay? And then the objective of this type of quasi-experimental research or design is to evaluate or to measure the effect of intervention, such as the intervention can be like a training program, teaching strategy, policy change, or a medical treatment. And the group of participants who receive the intervention is selected in a non-random way. Okay, it can be like convenient sampling, for example, but not random. This type of research design is characterized by having no control group, and they also don't have measurements before the intervention. Okay, or you can take a look at this simple diagram here to see what this type of design looks like. Okay, so that's it for the first one. Oh, actually, I have another point. Okay, it is the simplest, but the weakest of the quasi-experimental designs in terms of level of evidence. Okay, so that's it for the first one. Now look at the second type of quasi-experimental design. Static group comparison design. In this type of quasi-experimental design, the outcome of interest is measured only once again after exposing a non-random group of participants to a treatment. Then they are compared to a control group. See here, there are 2 groups here this time. Okay, the objective of this one is to measure the effect of a treatment or intervention, which can be, again, whatever you want to measure. So like a medical treatment, teaching strategy, whatever, or an environment event, for example. And this design has 3 major characteristics. First one, participants are not randomly assigned to either receive the intervention or not, which makes it quasi-experimental. The treatment and control groups are measured at the same time. And the last one, okay, no measurements are taken before the intervention. And the the static group comparison design is 1 step better. So it's better than the previous one that we just looked at. Okay, so that's it for for the second type. And then the third type, one group pre-test, post-test design. In this type of quasi-experimental design, the outcome of interest is measured 2 times. Okay, so 1 time, so you measure before and then after exposing your participants to a certain intervention or treatment. The objective here is to evaluate the effect of an intervention. And this research design has three major characteristics. First one, the group of participants who receive the intervention is selected in a non-random way, which again makes it a quasi-experimental design or study. The absence of a control group, there is no control group here. And the effect of the intervention is measured by comparing the pre and post-intervention measurements. Okay, so that's about one group, pre-test, post-test design. Okay, there's only one group here. And the last one, separate sample pre-test, post-test design. Okay, you can take a look at this simple diagram here. So in this type of quasi-experimental design, the outcome of interest is measured 2 times. So once before and once after an intervention, and each time on a separate group of randomly chosen participants. The difference between the pre-test and post-test measures will estimate the intervention's effect on the outcome. And the interventions can be, again, whatever you want to measure, a treatment, training program, exposure to some factors, or teaching strategies. Characteristic of separate sample pre-test post-test design include, first one, data from the pre-test and post-test can come from different groups. Participants are randomly assigned to each group, and all study participants receive the interventions. Okay. So that's it about the 4 examples that I wanted to show you. So now it's time for a quick test. So let's see if you can tell me which what type of research design each one is. Okay, so let's take a look at this example. So, okay, so I put the options down here for you, so you can take a look at the option and choose the one that you think is a type of this research. Okay, so a team of researchers conducted a quasi-experiment to study the effect of cray work as an art therapy on reducing the anxiety of 49 psychiatrists in patients, volunteers. In order to measure anxiety, a self-report questionnaire was used as a pre-test and post-test. The intervention was the creation of a cray pinch pot. The results showed that there was a statistically significant decrease in the anxiety score between the pre-test and the post-test from 46.8 to 39.3. Okay, now can you tell me what type of research design this one is? What do you think? You can turn on your mic and I'll answer the question and tell me what you think it is. Because if you type in the chat box, I won't be able to see that. Because like, okay, what do you think? Anyone would like to try?
Is it one group? One group.
One group, post-test, is that right?
Pre-post.
Okay, we've got 2 that begins with one group. Okay, which one do you think it is?
One group pre and post-test design.
Excellent, and that is the correct answer. Okay, so this one is an example of the one group pre-test, post-test design. Very good. Okay, so if you'd like, you can capture the screen. So if you want to take a look at this later. Okay, all right, so now let's move on to the second one. What about this study? A team of researchers conducted a study to evaluate the effect of an educational seminar on 24 medical residents regarding practice management issues. A questionnaire that measures the residents' knowledge on the subject was used as a pre-test and post-test. And the study concluded that there was a statistically significant improvement in the knowledge of residents after the seminar. Okay, what about this one? What is it? What design is it? So here we have pre-test and post-test, right?
is there still a one group?
One group.
I assume it's just one group because nothing in the report claiming like they are separating.
Yeah, you're probably right. But actually, this one is an example of, the one that you thought that it might be. Yes, it's a separate sample, pre-test and post-test decide. Okay, so maybe the description here is not that clear, right? Okay, but actually it's a separate sample, pre-test, post-test decide. This one, this study was, is a real one. Okay, it's not like a makeup one. It's a real one. So, but maybe just description is not clear. Okay, thank you for that. And then move on to another example. Okay, this one is quite long. I'm going to read this for you. So in 2011, researchers wanted to study if the CDI, what is CDI? Is a tool to measure depression in outpatients and can also classify inpatient children as having depressive disorders or not. So they want to test the tool of that. So they brought data from the archive of a medical center and selected children whose records contain a depression diagnosis at admission and a CDI score. So patients were divided into two groups, okay, the treatment group and the control group. In the treatment group, children diagnosed with, it contains children diagnosed with any type of depressive spectrum at an admission, and in the control group contains children diagnosed with any other psychiatric problem. Okay. So the CDI scores of the two groups were compared, and the study concluded that the CDI was in fact able to discriminate or differentiate between the two groups. Okay, so what type of study is this one? We only have two options left. Is it a study group comparison design or one group post-test only design? Okay, answer is static. Good. Okay, static group comparison design. Okay, and of course the last one is one group post-test only design. So let's see what it looks like. Okay, so a team of is it the last one? Yes. Okay. So a team of researchers design an exercise program for older adults based on traditional Chinese medicine ideas. They wanted to test its feasibility, like that medicine. They wanted to test its feasibility, safety, and helpfulness. So they conducted a study as a pilot test with 31 older adults volunteers. And then they evaluated these participants using open-ended questions after receiving the intervention, which was the exercise program. Okay, and the study concluded that the program was safe, helpful, and suitable for older adults. And this is, of course, the example of the one group post-test only design. Okay, so these are some examples of the quasi-experimental designs. Okay, so now I'm going to move on and talk about data analysis. So first, we'll take a look at descriptive statistics. Descriptive statistics can be useful for two purposes. You can use them for two reasons. Okay, first one, when you want to provide basic information about variables in a data set, and also you can use descriptive statistics in order to highlight potential relationships between variables. Those are two main purposes of descriptive statistics. And there are three most common descriptive statistics that I think are quite important to look at. Okay, first one is called measures of central tendency. The second one, measures of dispersion. And the last one, measures of association. Okay, but first of all, let me tell you that I'm not good at math. Okay, so math is not my cup of tea. Okay, but I conducted all my studies using quantitative design. Okay, so it's not that hard. Okay, so some of the things that I'm going to be talking about from now on might be a little bit complex or something, but okay, thank goodness you don't have to do that you don't have to do all of yourself. There's a program that will do that for you. All you have to do is to be able to interpret and understand the data or the result. Okay, so now let's take a look at each one separately. So let's begin with the first one, measures of central tendency. So measures of central tendency are the most basic and often the most informative description of a population's characteristics. And they describe the average member of the population of interest, okay? And there are three measures of central tendency: mean, median, and mode, okay? Can you tell me what mean is? What does it mean by mean, okay? What is it?
That's the average.
The average number, that is right. Yes, it's the sum of variables values divided by the total number of values. Okay, yes, what you said is exactly correct. And what about median? Median? Okay. Here again, let's go back to the topic here. We're talking about measure of central tendency. Okay, so this one is a way of looking at the this one, right? So median refers to the middle value of a variable. Okay, we're gonna look at some examples in a minute. Okay, so mean is actually the most commonly used measure of central tendency. Okay, but people use median too. And then the last one is mode. What do you think mode is? What it means by mode? Okay, mode is the value that occurs most often. Okay, now let's take a look at, I'm not sure if I'm gonna, if I should call this a practice or an example. Okay, practice and example together. So here, the incomes of 5 randomly selected people in the United States are as follow. Okay, first one, 10,000, 10,000, 45,000, 60,000, and $1 million. Okay, what is the mean income? Can you tell me what the mean income is from this example?
Combining everything divided by 5.
Very good. Okay, you might use a calculator. Okay.
I don't have the calculator in here.
Okay, yeah, for me, I can't have that in my head to have to always use calculator. And yes, and you said what you said is exactly right. Yes, you combine everything, add all the numbers here up, and then divide the numbers by 5, and you can come up with the mean income, which is $225,000. What about median income? So again, go back here. Median is the middle value of a variable. What do you think is the middle?
45,000.
Good. Answer is $45,000. What about the last one, model income? The value that occurs most often. And that is
10,000, right?
good, $10,000 because it happens twice. Okay, it's the only one that happens twice. Other happens only once. Okay, so model income is $10,000. Okay, very good. So this is the first one, measures of central tendency. Okay, move on to the second type of descriptive statistics, which is measures of dispersion. So what does it mean by that? Measures of dispersion provide information about the spread of a variable's values. We have range, variance, standard deviation, and then skew. Okay, so look at range first. What does it mean by range? So the difference between range refers to the difference between the smallest and largest values in the data. Okay, so let me just give you the definition of each one first, and then we'll look at some examples. And then variance, what does it mean by variance? Variance refers to the most commonly used measure of dispersion, calculated by taking the average of the squared differences between each value and the mean. Like I said previously, thank goodness we don't have to calculate all this by ourselves. The program would do all this for us. Okay, we just have to know what they are. Okay, and then SD or standard deviation refer to a measure of the amount of variation or dispersion of a set of values, and it is the square root again. Okay, square root of the variance. What about the last one, skew? Skew is a measure of whether some values of a variable are extremely different from the majority of the values. There are two types of skew. Okay, first one is positively skewed, and the second one is negatively skewed. So a variable is positively skewed, like positive, okay, positively skewed if the extreme values are higher than the majority of values. Okay, and the other one, which is negatively skewed. So variable is negatively skewed if the extreme values are lower than the majority of the values. Now look at a quick example. Okay, actually it's the same example, same numbers. So the incomes of 5 randomly selected people in the United States, again, are these, okay, numbers, 10,000, 10,000, 45,000, 60,000, and $1 million. So what is the range?
So we need to 60,000, right? The highest, right?
The highest is this one.
Okay, sorry.
Yes, okay. The highest
And then we minus 10,000, right?
okay, good. That is correct. And so what is the range? So if you have calculation with you, or if you are good at math or better than me, then you should come up with this number. This is the range here. What is the variance? Okay, see there are 2 lines here, the big space, because it's going to be long. So let me just show it to you here. So, so back to the definition, it's the most commonly used measure. Okay, so variance is calculated by taking the average of the square differences between each value and the mean. Okay, so quite complex here. So this is the variance for this this case. Okay, and then SV is the square root of this number, like this number here. And so here is the SD, or standard deviation. And the skew, is this one positively skewed or negatively skewed? Can you tell me?
Looks negative to me.
Negative to you?
Yep.
Let's go back here. A measure of whether some values of a variant are extremely different from the majority of the values. Answer here is actually, if you might not be able to tell easily, like more that easily when just looking at the numbers like that. But if you look at the graph or histogram or something like that, it will be clear. Okay, answer is actually positively skewed. Okay, I never have to figure out whether it's a positively skewed or negative by just looking at the numbers. It will be too complex. Okay, but you can tell by looking at the some sort of figures that will come out from SPSS program, for example. Okay, so that is it for the second type of descriptive statistic. Now we come to the last type of descriptive statistic. It's called measures of association. Measures of associations indicate whether 2 variables are related. You want to see if this one and this one are like related to each other, like that. So one measure is commonly used as one measure that is commonly used. There are other measures that can be used to see if there is an association between the 2 things. But the one that is commonly used is correlation. A correlation coefficient is used to measure the strength of the relationship between numeric variables, which can be, for example, like weight and height. You want to see if these 2 are related. Okay, and then the most common correlation coefficient is Pearson's R. Okay, I'm sure that everyone is familiar with this one. And the value of Pearson's R can range from -1 to +1. Okay, so that's the value of Pearson's R. Now, there are 2 types of correlations. The first one is called positive correlation, and the second one is called negative correlation. So look at the first one first. If the coefficient is between 0 and 1, and that is called positive correlation. That means when as something goes up, the other thing goes up too. Or as something goes down, the other thing goes down too. So that is called positive correlation. let's take a look at this example. For example, height and weight are positively correlated because taller people usually weigh more. Okay, so that is the example of positive correlation. Now, what about negative correlation? So if the correlation coefficient is between -1 and 0, then it is called negative correlation. That means as something goes up, the other thing goes down. Okay, or as something goes down, the other thing goes up. Actually, these two things are the same. Okay, so for example, 8 hours of sleep per night are negatively correlated because older people usually sleep fewer hours per night. Okay, so this is an example of negative correlation. All right, so now we are done with descriptive statistics. Data can actually be displayed, not always in forms of numbers. Data can also be displayed in many different ways. Okay, so plots like bar graphs, histograms, stem and leaf plots, box plots, or scatter plots are a ways of looking at a lot of related values without looking at a bunch of numbers. Okay, that is kind of painful, especially for me. Okay, so it will make your life easier having these things here. So they help you quickly see how numbers are related to each other. So these are things that we will be looking at from now. Okay, so let's begin with the most common one. So we've seen this like we've known about this for a long time. Okay, like for me, I learned about this when I was like little. Okay, so bar graphs. So let's see here. Here's what a bar graph looks like. They may look a little bit different from one another, but this is one example of a bar graph, and I'm sure that you all are already familiar with bar graphs. So let's take a look at information displayed in this bar graph, and can you answer some of the questions that I'm going to have? So first one, based on the information presented here, what does the bar graph show? What does this bar graph show?
The population of the 3 types of bear in North America.
Of course, very good. Okay, this bar graph shows the population of different species or different types of North American bears or bears in North America, like that. Okay, very good. What about second question? What are the numbers on the left side of the plot? Left side over here.
The number of the bears?
Yes, there are numbers that represent the bear population, and the titles over here on the bottom of the bar graph tells you species of bears. Okay, we have black bear, we have brown bear, we have polar bear. Last question, how many black bears are there?
It's 800,000.
800,000.
Good. How many zeros do we have? 1, 2. Okay, so kind of small. Yes, answer is 800,000 black bears. What about last question? How many polar bears are there?
Low.
Very low, yes, like around, okay. Yeah, the number is not there, but you can maybe say that probably around 20 to 25,000 maybe. Okay, like around that. Not a lot at all. Okay, so that is it about bar graphs, and I'm sure, like I said, that everyone is already familiar with this type of figure. So what about histograms? Okay, you all see histograms all the time when you use SPSS. What are they? A histogram is actually a type of bar graph that shows how many something occur, okay? Also called frequency. Okay, it will show the frequency. So a histogram looks like a bar graph, except that the bars are adjacent, and that means there is no space between the bars, between them. Okay, so without any space between the bars, you can see how the counts and values are related to each other. And many times the values will look like a normal distribution, but not always, but most of the time it's like that. Here's an example of a histogram. Here's what a histogram looks like. So here's a description of this histogram. So the SAT test is a test that many students take before they go to college, and many colleges decide who to accept based on the SAT score, based on this score. So it's quite important. So one part of the test focuses only on math, and the test score ranges from 200 to a maximum of 800 points. And here's a histogram of the percent of students taking the math SAT getting scores in each range of 100. Okay, so this one is like 100 scores apart. Okay, and so from 300, starting from 300, this one here, to 700. It's quite small, but okay, it's okay. It's good enough to understand what a histogram looks like. So now, what do we know from looking at this histogram? What can you tell me from looking at this histogram? Okay, first of all, you can say that almost all students scored over 300. Almost all. There are some people who score like 300, but almost all other people score more than 300. The second thing that you can tell from looking at this histogram is that most of the students score between 400 and 600. Where's 400? Okay, 400. So most of them scored around here. And then the next thing that you can tell from this histogram is that the very best students scored 700 or more. Okay, around here. And then last one, this histogram also shows the curve of normal distribution. The majority of people are like in the middle. Okay, so this is a normal distribution. So that is it about histogram. Now we are going to move on to the next type of figure, which is called box plots. Okay. Have you ever used box plots in your study? Okay. And like I said, thank goodness we don't have to create or generate the box plots by ourselves. The program will do all this for us. We just have to understand what they are. Okay, a box plot. Sometimes called box and whisker plot. Okay, this is a box and these are whiskers. Okay, the lines over here, whiskers. So that's why they are sometimes called a box plot, a box and whisker plot. Okay, it's used to picture the distribution of values. When you use a box plot, you divide the data values into 4 parts, and these parts are called quartiles. Okay, there are 4 parts: 1, 2, 3, 4. You start by finding the median or the middle value. Okay, we look at this one previously, and the median splits the data values into halves. Finding the medians of each half split the data values into 4 parts, or the quartiles. And here's the anatomy of a box plot. Okay, so here is the upper extreme, upper quartile. This one is called median, lower quartile whisker, and then lower extreme. Sometimes you may have outliers or single data point too. So each box on the plot shows the range of values from the median of the lower half of the values at the bottom of the box to the median of the upper half of the values at the top of the box. And a line in the middle of the box occurs at the median. Okay, this one is median of all the data values. The whiskers then point to the largest and smallest value in the data. Okay, so the whiskers pointing, this one is pointing to the highest, right? The largest, and this one is the smallest values or the lowest values. Okay, so this is the anatomy of box plot. Okay, look at an example. Let's take a look at the real one. So this box plot shows the temperature range of an unnamed cities in the United States. We don't have the names of the cities. We just have city 1, city 2, city 3. Okay. So now I have, how many questions do I have? 2 questions. Okay. Based on the information displayed in the box plot here, which city has the warmest weather? Over here is the temperature, right? Temperature. cities. There are 3 cities we are looking at right now. So which one is the warmest? Which one has the warmest weather?
City 2.
City 2? Everyone thinks so?
Number 2, yes,
Number
number 2.
Yes, very good, excellent. It's City 2 that has the warmest weather. Okay, that's what we know from looking at this box plot. What about this one? Which city do you think has the most variable weather and why? How did you know? What tells you?
Is it number 3?
Is it number 3? It is. Very
Oh.
good. Okay, good job. So why? Why do you think so?
Because the box is relatively longest compared to the others.
Yeah, exactly. Okay, answer is city 3 that has the most variable weather. And city 3 must have cold winters maybe and very hot summers maybe. Okay, so like the temperatures are quite different, like throughout the year. So we can tell from the range of temperature at the end of the whiskers over here, okay, that this city will have the should have the most variable weather. Okay, so this is all about box plots. So very so that's all I know. Actually, I don't know a whole lot. I also include some box plots in my study too, but I don't explain very much. Just tell them, show them the figures and just like say a few sentences and that's it. Okay, so now another type that I want to talk about is called stem and leaf plots. Okay, this is another way to show frequency of data. Okay, so another way to show frequency of data is to use a stem and leaf plot. So when you make a stem and leaf plot, you use the actual values as they were recorded. Okay, use the actual values. And then you take the first digit of the values as the stem. Okay, let me show you the picture so you can see it too. So you take the actual values, okay? But in order to make a stem and leaf plot, you have to take the first digit of the value as the stem. So, okay, the first digit, okay, as the stem. So these are stems. And put it on the left of the plot. Then you write down the rest of the digits of each value on the right, okay, over here like this. So a sample stem and leaf plot for a group of students taking the math set that we just looked at previously, okay, would look like this. So next to the 3, you put all the scores in the 300s. So that means, what is the actual score of this one? This one is actually, what is the score of the student? It's actually, is it actually 40? No, it is
340.
340. Yeah, because this is the last 2 digits of that number of that score. So this means, what is the actual score of this one? This one is 370, right? Okay, and other ones too, like this one, is it really 20 points? No, it's actually 720. Okay, so this is how it works. So you can kind of see the distribution of the scores, right? Okay, so now scatter plot. Okay, last one here. A scatter plot is an excellent tool and frequently used for comparing pairs of values to see if they are related. Now look at this example. Suppose that you are researching shopping trends. So you want to know when people shop in your store, and you like put people, like station someone at each door in order to count how many people enter the store at 15 minutes intervals, like every 15 minutes. So you count how many people who comes in between 9 and 9:15, okay, and then 9:15 to 9:30, and so forth, like every 15 minutes. Okay, so this is what you want to do. So here is what our scatter plots look like. So after the survey, you plot the data for a 3-hour period, which gives you 12 points on the scatter plots based on 15 minutes time slot. So you have how many? 12 spots on this scatter plots. Okay, so let's say the scatter plot looks like this one for data gathered in the afternoon. There doesn't seem to be any relationship between, it's like everywhere. It's like, okay, so there doesn't seem to be any relationship between the time period and the number of shoppers. Okay, it's like everywhere, like I said. So you try another one. Now you measure the number of people coming into your store for the first 3 hours after the store opens. So this time you can see that the number of shoppers entering the store in the morning steadily increases. And so the scatter plot here shows you the trend. Okay, so you can see the correlation. They see that they are the two factors are related. Okay, so this is what scatter plot looks like. Okay, so that's it about the figures that you can use when interpreting your data. Now I'm going to move on and talk about null hypothesis and alternative hypothesis. Have you ever heard of these two? Okay, in quantitative research, you will be familiar with these two types of hypotheses. So first one is called null hypothesis, and then the second one is called alternative hypothesis. So let's begin with the first one. Null hypothesis are denoted by H0. Okay. This hypothesis is a general statement that states that there is no relationship between two phenomena or two variables under consideration, or there is no association between two groups, and it is the hypothesis that you or all researchers would like to disprove, would like to nullify, would like to reject. Okay, you don't want it to be true. Okay, that is called null hypothesis, saying that there's no difference between the two groups, or there's no statistical significance between whatever you are comparing. And then now look at alternative hypothesis, and you can that is denoted by H1 or HA. Okay, but most of the time I see H1. Okay, but HA is okay too. So this an alternative hypothesis is a statement that describes that there is a relationship between two selected variables in a study, and it is a hypothesis that the researcher tries to prove. You want it to be true. You want this to happen. Now look at an example here. Effect of biofertilizer X, this is the name of the fertilizer, on plant growth. Okay, this one on this side, alternative hypothesis. You really want this to happen, okay? So this is the null hypothesis. So what should I say for the alternative? What should alternative hypothesis says? Okay, for H1, it is like this one. Okay, it is this. Application of biofertilizer X increases plant growth. Okay, so this is alternative hypothesis, and you want to prove this. You want this to be true. Okay, as a researcher. What about null hypothesis? What is it supposed to say? Application of biofertilizer X, what?
Doesn't increase their plant growth.
Good. Okay, so that is null hypothesis. Application of biofertilizer X does not increase plant growth. Okay, so these two are, okay, this is an example of alternative hypothesis, and this is an example of null hypothesis. Okay, why do we want to know all about this? Okay, so let's move on. So how do we know if your results are statistically, did I skip a slide? Okay, let me go back. No, okay. So how do you know if your results are statistically significant? Okay. That is when the p-value comes in. Okay, the p-values is there for each test. So SPSS gives you this p-value, and and p-values, this PSS give you this p-value, and the p-values is there so that you can determine whether you can go with the null hypothesis or the alternative hypothesis. Okay, so now the rule is, oh, okay, so first let's go back to the letter here, the name here. So the letter P there stands for probability. Okay, and this probability, okay, this one takes the value between 0 and 1. So what is the rule here? The rule is that if the P value is low, we reject the null hypothesis. Okay, or you can say the P is low, the null must go. Okay, I used to keep saying this when I was a PhD student. It's like always in my head. Okay, and now I'm reviewing this topic again. It's going to be in my head like for a while again. Okay, so when the P is low, the null must go. Okay, so that means when the P value is low, the null hypothesis will be rejected. Okay, so that's what it means. So the P is low, the null must go. So we are going to need some kind of threshold at which we can say what low means. Okay, it's quite subjective. Okay, what do you mean by low, right? So in majority of analysis, an alpha of 0.05 is used as a cutoff for significance. And the term significance here has a very particular meaning in statistics because it tells you how likely it is that your result has not occurred by chance. If the P value is less than or equal to 0.05, then we reject the null hypothesis and can conclude that there is a statistically significant difference between the means. Okay, and this means that we reject the null. Okay, what does it mean by all this? Okay, it means that we reject the null at the 95% confidence level. And that actually means there is a 5% chance that we could be wrong. Okay, so you allow like 5% mistake, okay, something that could come up, something like that. Okay, but it's good enough this level. So if your p-value is greater than or higher than 0.05, then the null hypothesis cannot be rejected, and that means there is no statistically significant difference between the means or the outcome that you get from the two groups of participants that you are comparing, or so there are no difference between the two groups, for example. So here are other significance levels that can also be used. Okay, you can have the alpha set at 0.01, 0.05, or 0.10. Alpha set at 0.01 means 10% significance level. And if you can reject the null at this level, it means that you may conclude that it is very strong evidence against the null, very strong. Okay, so for this one here, 0.05 means 5% significance level. So here, if you can reject the null at this is 5% significance level, then you can conclude that there is strong evidence against the null. What about this one? Okay, this one is also used too. So if you can reject the null at 1% significance level, that means there is weak evidence against the null. Okay. But mostly this one is used, okay, the one in the middle, 0.05. So if SPSS gives you a p-value of 0.02, what should you conclude? Is this significance? 0.02? Is your result significant or not?
Yes, it's significant, less than 0.05.
Okay, good. Okay, answer is that yes, the p-value is less than 0.05. Okay, this one, if we can look at this one. So we conclude that there is strong evidence against the null. But now is 0.02 this value less than 0.01? Can you reject the null at this significance level? Is it less than 0.01? No, okay, it's not less than 0.01, it is bigger than 0.01. So we would not reject the null at the 1% significance level. So in this case, we reject the null at the 5% significance level, but not at the 1 significance level. So we can conclude that there is strong evidence against the null. Okay, but here let me tell you about what is it called? A p-value. Again, this is not the same as the like. Doesn't mean that it's okay. It only tells you whether something is related to the other, whether there is a relationship between two things. That's all what it's here for. Okay, so it's not tell you like a lot or not a lot. It's not that you are going to need a different measure in order to find out about that. Like the effect size, yeah, I'm talking about the effect size. It's not telling you about the effect size at all. Okay, so how about if you get a p-value of 0.15, what can we conclude? How can we conclude if we get the value of 0.15? It is not significant. The value of 0.15 is bigger than 0.01, bigger than 0.05, even bigger than 1.110. So here we cannot even conclude that there is weak evidence. Okay, it's not significant at all. Okay, so in this case, there is no evidence against the null. In other words, your data does not support the alternative hypothesis. Okay, all right. So now look at SPS output here. In SPSS output, the p-value is labeled as SIG, S-I-G, which stands for significance. Can you tell me if any of these is significant?
The intercept for sure.
Which one? Oh yeah, this one, right? Okay, okay. And from what I know is that a p-value can never be zero. Like you can say less than 0.01. 0.01, I'm not sure, but okay, SPSS will generate the number, the value that looks like this. Yes, this is significant. Okay, and then another thing that is significant is gender 0.004. Okay, so very good. So here, look for this column when you want to see if your results are significant or not. Okay, you can look for this one. Okay, so now I'm going to quickly show you a study that I conducted using a quasi-experimental research design. So we can see a more concrete picture of how a quasi-experiment looks like. Okay, so this study was conducted based on the cognitive theory of multimedia learning, and particularly the redundancy principle, and it was published in this Journal of Educational Multimedia and Hypermedia. Okay, and this is the topic of my study, examining the effect of different multimedia learning environments on the learning outcomes of second language learners. So I'm going to talk briefly about my study so you can have a clearer picture of how quasi-experimental research can look like. Okay, so my study was based on this theory, cognitive theory of multimedia learning by Richard Mayer. Okay, so let me show you briefly what redundancy principle is so you can understand my study better. So based on this principle, we believe that people learn better and more deeply from pictures and narration than from pictures, narrations, and on-screen text. So like having two is better than having all three, okay, based on the principle. Then we should get rid of on-screen text when you have narration that already reading those words on screen, so you don't need on-screen text because it's going to be redundant. And you should avoid overloading the visual channel and describing graphics using both on-screen text and narration repeats the text. And this redundant information can overwhelm the brain because you are trying to read, see, and listen all at the same time. So that's what the theory says. Okay, so you can take a look at this diagram. So here you can, if you have all three things here, okay. If you have all of them here, so you have narration, okay, like the audio, okay. So the narration can goes into your ears and is processed in the auditory channel. Animation or pictures that you are looking at will go into your eyes and is processed in the visual channel, and that is good. But then if you also have on-screen text, okay, it's also going to go into your eyes and will also be processed in the visual channel. So that way you will overwhelm or overload the visual channel. This is not a good thing to do based on the theory. So a better way is to remove that. So you should remove the on-screen text and just have two things there. So narration and animation. Okay, so that way we believe that people can learn better and more deeply. Okay, so here's my research question. Do second language learners who are presented with a multimedia learning containing multimedia lesson containing only images and audio, like two things, differ in subsequent comprehension performance from second language learners who are presented with three things, okay, with a multimedia lesson containing images, audios, and on-screen text. Okay, so that is my research question. So here is the methodology. For the instrumentation, there were two sets of instrumentation. First one is the learning materials. There were two multimedia learning environments, which were images with audio, and then images with audio and on-screen text. Okay, and then the content in both multimedia learning environments was exactly the same. The lesson was 20 minutes long, and it was about basic science concept that had nothing to do with the class that the participants were in at the time. And the entire lesson was in English. Okay, and the pre-test and post-test that I used consisted of 20 test items asking about or testing their knowledge about the content presented in multimedia learning environments. Okay, so these are the things that I use. Okay, so the participants, 230 undergraduate students participated in this study. They were in the same English course, and they were also in the same academic disciplines. They also were in the same, pretty much at the same age, like between 18 to 21. Here's my research design. Okay, there are two groups here. The first group here contains 113 people. First, they took a pre-test and then they engaged with a multimedia lessons containing images and audio, and then a post-test was given to them to measure their learning outcomes. Also, the second group, okay, there were 117 people in the second group, and then the pre-test was administered, and then they engaged with the multimedia lesson containing three things: images, audio, and on-screen text, and then they were given a post-test to measure their learning outcomes. Here's my data analysis. So a repeated measured analysis of covariance, or ANCOVA, was conducted to evaluate change in comprehension performance between from pre-test to post-test, mean differences in comprehension performance between the two groups that I just showed you, and then group differences in comprehension growth from pre-test to post-test using gender and English proficiency as control variables. I want to make sure that these two factors did not affect the outcomes of the study. Okay, and after that, another analysis of covariance, or ANCOVA, was carried out in order to measure group differences in post-test scores, and this time controlling for gender, English proficiency, and pre-test. And here, eta squared and coincidences were used in order to compute the effect size, because like I told you, p-values doesn't tell you the effect size. You have to compute the effect size if you want to know that. Okay. Here are my results. So here are the results for the repeated measure of analysis, or repeat measures analysis of covariance, or ANCOVA, of comprehension score across time by group and gender. So overall participants were found to improve significantly from pre-test to post-test. Okay, you can look at the p-value here. Okay, so time. Okay, time here means pre to post. Okay, so everyone seemed to improve significantly okay, in both group. And there was no statistically significant in growth from pre-test to post-test between the two groups because p-value was 0.635. Okay, so this one is not significant. Also, there was no significant difference in growth between males and females because p-value was 0.449. However, that was a significant three-way time by group by gender interaction effect over here. As you can see from the p-value here, which is 0.017. So this one is significant. So it was found that males were found to perform better under the images with audio and condition. And females appear to perform better under the images with audio and on-screen text condition. So the females appear to perform better when on-screen text was present on screen. So here you can see the graph, the figure here. So here is for participants. You can see that participants improve significantly from pre-test to post-test. So the solid line here represents the people in the images and audio group. The dotted line here is for the group that had three things that are images with audio and on-screen text. And one is pre-test, two is post-test. So you can see that everyone appear to perform significantly better from pre to post. Now this one is for males. So if you look at this figure here, you can see that males appear to show greater comprehension growth in the images with audio group. Okay, so like that. And then this one is for female. So as you can see here, females tended to show greater growth in the images with audio and on-screen text group. Are we running out of time? Okay, we have 5 more minutes, right? Okay, so here is the result of another or the second analysis of covariance or NCOVA. So I did it 2 times. So here, a test of between subject effect indicated that group and gender did not have statistically significant effects on the post-test scores. Okay, the p-value for the group was 0.854. Okay, for the group. Okay, so the 2 groups are not statistically significant. And then also for the gender, like male and female, the p-value was 0.6331. Okay, this is also not significant. But again, you can see that there, this one is significant, 0.017. Okay, so that was a significant group by gender interaction effect on the post-test score. So this one, we only look at the post-test scores, not the growth score. The previous one was for the growth score, and this one is only the post-test scores. Okay, so here's the table. Here's the table. Like I said, it's not the 2 groups are not statistically significant difference between one another, but you can see here if you look at the mean scores. So this is for the images and audio group, and this one is for images with audio and on-screen text group. You can see that the mean in this group is a little bit higher than this group. Okay, just a little bit. So that's why it's not significant. Okay, so here are, maybe we don't have time for discussion, I'm not sure. Okay, so maybe that's it, because I just wanted to show you what a quantitative, what a quasi-experimental research looks like. Okay, so hopefully everyone learned something new about quantitative research, and in particular quasi-experimental research. Okay, so that's all. So it's bringing me to the end of my presentation. Okay, so thank you everyone for your attention and for being here on Sunday morning. Okay, thank you so much. Do you have any questions or anything that you'd like to ask? I'll try my best if there are questions.
Is there anyone would like to ask
Let me
some questions?
so we can see each other.
Thank you. Anyone would like to ask some questions to Ajahn Araya ka? Okay, anyone or anyone that talks, we've got
I see a text.
Kun Duong Rutai. Thank you very much, Dr. Arayana.
Thank you, Ajahn Duong Rutai too. Thank you, everyone.
Right.
Okay.
And anyone else? All right. If there's nothing else, So thank you very much, Ka Ajahn Araya, for that we got today. Is very thorough, and I'm sure it will a lot of our students to continue the experimental research pathway. And let me also tell you, she's actually an analyst from LITU as well as part, well, someone you might want to look up to if you're a student and want to continue the pathway. Right. And so right now, could you please, okay, I'm going to share this. Could you please complete the evaluation form? You can do so by going to follow the link that has been sent to you, or you can, okay, just one moment. All right, so you can do so. Okay, right.
January, I already shared it in the chat box.
Screen. Right. Okay. So there are two ways that you can go. So you can use the link on the chat box, or you can scan the QR code on the screen to give us the evaluation. And also, if you would like to receive the certificate for attending this seminar, please, you will need to also fill in the evaluation form. And at the end, you will see that you get to give us the information about your title, your name, and also please give us your correct email address so that we can send you the certificate for attending this webinar later. All right, so everyone got this? Okay, right, okay. All right, you can do that through the chat box, all right? Okay, if there's nothing else, thank you very much, Ajahn Araya. Thank you again.
So much, Ka, for inviting me, for having
Also, thank
and for being
attending.
Ka. Thank you, Ka.
Right, and I really wish I could work with you again in the future. Thank you very much, Ka.
Thank you so much, Ka.
January, do we need to take a photo?
Oh yes, please. Oh, I forgot. Sorry. Thank you, Ka. All right. So, right. So if you would like to take photos with us, can you please turn on the camera? Oh no, some people have left. I'm sorry. A little bit new to webinar, so sorry. Okay, ready? 1, 2, 3. Smile. Okay, one more time. 1. Okay, little boy. Okay, come on. Okay, 1, 2, 3. Okay, got it. And then okay, I think the picture might be uploaded to our Facebook page, or maybe I'll send the picture to your with your certificate. Right. Thank you very much, everyone.
Thank you so much. Have a great day, everyone. Bye.
Thank you very much.
Thank you so much, Ka.
Thank you.
ออกได้เลยไหมคะอาจารย์
ออกได้เลยค่ะอาจารย์ขอบคุณมากนะคะ
ขอบคุณค่ะ
อาจารย์ขอบคุณครับขอบคุณค
ขอบ
รับ
คุณค่ะขอบคุณ
เราส่งค่ะสวัสดีค่ะขอบคุณนะคะ
ท่านค่ะ
พี่แตงขอบคุณนะคะ
ครับขอบคุณครับไม่เป็นไรครับ
ขอบคุณค่ะเอเลนา